and we'll jump into advanced searching and topics that go into that. Okay, so as far as what I want to cover today, we're going to go over a few different things. First thing I want to hit is talking about searching with multiple keywords. We've done it with one keyword so far, but we haven't touched on how to do it with multiple keywords. In there, we'll also talk a little bit more about deferred execution and this interface called iQueryable, because you need to understand a little bit of that to understand how this multiple keyword searching works. And then we'll talk about HTML5, autocomplete, autofill. Those parts are relatively new. There's a lot of stuff that's changed in the last 2 years. So starting 2017, there's a new standard that got put out, and that's changed how we set up a lot of our forms, especially registration forms or checkout forms. So that is kind of related, but it's somewhat on a different topic that's a little bit bigger than just search boxes. But it is a related topic that you want to kind of know about. The next thing we'll get into is looking back at jQuery UI. You probably got an intro to this in your first semester. We maybe didn't talk too much. You probably didn't talk specifically about this widget. But there is an autocomplete widget that's part of jQuery UI. And the nice thing is, what it's going to actually let us do is it's going to allow us to easily hook that into a web service. So we can have a web service that gives us those suggestions and also gives us some spell checking on that. So that's going to make this search box a lot more powerful by having that web service in there. Okay, so that's kind of where we're going, right? That's the broad scope of where we're going. So let's look at first, how do we implement this? Let's say I want to have a search that's more than one page. Can I get into, I may have to pull up the PDF so I can get full screen on this. 1 second. Let me get to my downloads. There we go. Okay, that gives me some more space on screen. Can everybody see that? I don't know, that looks a little bit washed out from here. A little bit bigger. Okay. Yes, this is on Inside Rankin. Okay. So, starting kind of up at the top, we've called this method's called index. We've got 3 parameters coming in. We've got Q, which is the query string, whichever you typed into the search box. And then we've got our paging stuff. So that part we're familiar with, those 3 parameters coming in. Okay, now what I need to do is I'm going to kind of change how we've structured this index action. Okay, so if we look at that first line, you'll notice that I've kind of started to break things apart. So the first thing I'm doing here is I'm just grabbing the table, db.things. Assume this is the products table, or your resumes table, your work orders table. This is the table that we want to search through. And I'm taking that and putting this into this variable called query. Okay? So that's the first thing I'm doing. And if you need to do any joins, if you need to do any include statements, that's where they would go in that first part. You're just saying, what data do I need and where is it going to come from? Okay? If you're using a view model in there, things like that, all of that would go there first. Does that make sense? The first trick is you just want to figure out what data do I need. In this case, I'm only pulling it from one table. Okay? So I'm saving this as type iQueryable thing. That turns out to be really, really important, that specific data type that I'm using at iQuery. And I'll come back to that as to why that needs to be there. But let's just start by assuming that's kind of the data type that has to be there. Okay? But that's what allows me to do what I'm about to do, where I'm building up the query as more than one line. If I didn't do that, then I'd have to put everything on one line to make it work. Okay, so the next thing I'm doing is I need to build up the where clause. So effectively, I've kind of joined the tables. I figured out what data I need. The next thing I need to do is filter the data, which is where this part comes in. Okay? So the first thing I'm saying is, have you specified a query string at all? Okay? Is it null or white space? Right? So if you haven't given me a search string, or you're just initially visiting this page, we're going to skip by all of this, and there will be no where clause. Does that make sense? There's going to be no where clause because I'm not going to add it. Okay? Now, let's see what happens here next. So the next thing I need to do, again, is this is to support multiple keywords, right? So the next thing I need to do is split the string up based on spaces. So I assume that multiple keywords are separated by white space. That make sense? So if you're looking for John Kennedy, it's going to be John and Kennedy, but I need to break those into two different words because there's space in between. Okay? So that is what this regex split does. This regex split returns a string, an array of strings that are each of those words that are split on whatever separator I specify. Okay? So here I'm specifying that separator. You see that? Okay. This, again, and you can guess this maybe because this starts with the word regex, with the regex class. This is what we call a regular expression. Okay. What I'm putting in here is the separator. Okay. The reason I'm using this over string split is because it allows me to do things that are a little bit more advanced, and it's going to allow me to deal with things like tags later towards the end of this and have them split where string split wouldn't work as well there. Okay, so what I'm saying here, and let me just write that on the board so we can kind of break it apart, because there's a lot happening in those few characters. Okay, so that's what I have there as my regular expression, right? I'm going to give you a marker that's a little bit darker. Okay. Erase that because it got messy real quick. Okay, that's better. So the first thing I have here at the beginning is that @ sign. Okay, that @ sign is generally something you always want to put anytime you're doing one of two things. If you're specifying a regular expression, or if you're specifying here's a path to a file. Okay, in those two cases you want to start with an @ sign. So why is that? Well, let's start with files because that's one that you're maybe familiar with. Well, what the @ sign does is it says don't treat slashes specially, right? So remember, normally if I write into a string, let's say I write /n, what does that represent? It represents a new line, right? If I write /t, that represents a tab, right? If I write /r, that's a carriage return, right? So anything that starts with a slash is treated specially. Or if I want a single slash, then I have to write things as double slash. Does that make sense? So without the @ sign, that's how slashes get treated. They get treated as special things, which means anytime I want to write a slash, I have to write 2 slashes. Well, in file paths, well, there's a lot of slashes. That's pretty common. So if you put an @ sign in front of that, you don't have to double up your slashes. Does that make sense? The same thing happens with regular expressions where we use slashes to mean something special more often than not. So if we don't put an @ sign in here, there'd be a lot more slashes in this regular expression than we needed to. In this case, it's just 2, because this one slash in here would just have to be 2, but it means that any slash that I have has to get doubled. Does that make sense? So that's the reason I'm putting the @ sign there in front of a regex, is to avoid doubling the slashes, which keeps it more clear as to what's going on. Okay? So that's that first part. So this part is to, why is that not writing well? So that's to treat slashes as slashes.
So you can't use other escape sequences.
None of the escape sequences work anymore. All the letters that I put in the string are now literal characters. That makes sense? So this slash s is not treated as a special character. It's treated as a slash and then an s. Okay? Now, slash s, what that is a special group of characters. I'm saying here, I want to match a particular group of characters. Again, going backwards a little bit, the whole point of a regex is to match a series of characters in a string. Okay? So what I'm saying with slash s is I'm matching a particular group. Okay? And that group is all white space characters. So slash s, I'm saying here, is any white space character. Okay. Capitalization here is a little bit important because if I have slash in an uppercase s, that's actually the reverse. So with an uppercase s, it's any non-white space character. Okay, so lowercase s is white space, uppercase s is non-white space. Okay, so what consists of a white space character? What are some examples of white space characters?
Carriage return.
Carriage return would be one. What else?
Space or tab.
A space or tab. And there's a fourth one. So we said carriage return, space, tab. What's the final one? So carriage return is slash r. Remember slash n, right? Both slash r and slash n are treated as white space. That makes sense? So those four different characters are treated as hey, we're going to ignore that. We're going to treat those as a separator between the words. Does that make sense? Now, if I just had this by itself, that would treat a single white space character as our separator, right? But I might want to support the user having more than one space, right? Maybe they put 3 spaces between a word. I still want to treat that as one space. So I've got this symbol here at the end called, I have this plus symbol, right? So that plus is going to say one or more characters of what comes before, one or more copies of what comes before. So plus, anytime we put that after a character in a regular expression, why is my marker not doing it right? I just need a different paper. There we go. One or more. So that's what that is. Also, on a related note, if I do star, if I do an asterisk, that's going to be 0 or more. And if I do a question mark, that means it's optional. So it's either it's there or it's not. Does that make sense? So these three special characters say that previous thing that I just wrote, it can happen this many times. Okay? So effectively what I'm saying is my separator is any sequence of white space characters. That make sense? Any sequence of one or more white space characters. Okay. If I put a star in here, that would be a problem because that would say 0 or more. which means that every character would get broken up into a string. So let's say give me 10 characters, I would end up with an array of all the characters split out, potentially. Because, well, no white space, that matches anything, so that can match in between. So that's what's going on there. Any questions about that regular expression now? That's a thing to file away, that kind of information, because regular expressions come up a lot, and they'll come up again later in this process when we're splitting tags. Okay, so that's what's happening here. So effectively, by doing this, we're ending up with an array where each string in this array is a single keyword. Does that make sense? That's all I'm trying to do there. Okay. So once I've split it up, now I can loop through the keywords. Okay. So I'm going to use a for each to go through each of the keywords, and in each time through the loop, I'm going to add something to the query. Okay. You can kind of think of what I'm doing here as sort of like a plus equals. I'm adding something, appending something to the SQL. Okay. So what I'm doing here is take this query that we've already started here and add a where clause to it. Okay. So we're going to take the query, add a where clause, and then save it as the query. So every time I do this, I'm adding another clause to the query.
How are you adding it when you're just setting equal?
Well, you see I say query.where. I'm taking the query, I'm saying run those results through this where clause, and then those results I'm saving. Does that make sense? I'm saving the results of the where as query. Okay. I'm not saving query as query, I'm saving the where as query. Okay, so in this where clause, I can put anything I want, really. But specifically what I've done here is I've said, well, let's use this word and look for the word in the name, the tags, the description, and the category, right? That can be whatever you want. Whatever group of columns that you want to search for, you want to use that keyword in, you just put that list of columns. Does that make sense? So you just pick and choose what those columns are going to be. So for instance, for your resumes, what would you probably want to look in if you're looking for resumes?
Name, email, and start update, or start last update.
Well, last update, the problem is last updated is a date, right? So this only works with strings, right? Because these keywords are strings, so I need to match them to strings, right? So full name I can do, email I can do, LinkedIn username.
You probably want to search by keywords in the description. So if you want to look for certain companies that they've worked for in the past and whatnot.
Right. If I wanted to do things like that, look for their skills or look for their jobs. The thing you have to remember though, are their jobs in that same table? Are those jobs in the resume table?
They're not. No.
They're not, right? So I would have to do something up here to join those two tables. Does that make sense? If I want to use the data from another table, I'm going to have to join it in up here as the first thing I do.
Couldn't you use navigation properties?
You can't. Because when you're dealing with the where clause, in a where clause, you cannot use navigation properties as a typical rule. The reason is because that can't be turned into SQL. Does that make sense?
Yeah.
It can't be directly turned into SQL. If you're using navigation properties in a where clause, there's not a good way to do that. If you're using just straight up properties, right? Like you've taken a view model, you've taken them somehow and transformed them into some sort of view model, then you can work with that. Okay. But navigation properties effectively are something you can't use in a where clause. Does that make sense?
Yeah. So
Again.
when here's like if you had a property that wasn't mapped,
Okay.
that was like only a get thing, so it does maybe some calculation, then you could use the where clause with it.
What do you mean?
So like, I remember I had some calculated columns that you could like, so you could have columns, or I guess columns that are properties that aren't
Mhm.
mapped to the database. You could use those.
No, you can't use not mapped. As far as, remember this part here, this part's still going to get turned to SQL. So if it's
Okay.
not, if it can't turn it into SQL, it's not a valid thing to use there. So I can't use navigation properties there. I can't use any column that's not mapped. These have to be actual physical columns in the database because what I'm writing here is going to get turned into an actual SQL where clause. And that's what I want it to be, right? The whole point of this is I want to build up a query in more than one step that's still going to run as one SQL statement. Okay, does that make sense? Eston? Right? Brandon? The whole point here is I'm trying to build up a single select query. Okay, so that's what that looks like. Okay, so I've built up this query right now, and so far we've got what table is it going to come from and what's my where clause, right? Now the nice thing of how I've set this up, this query I can actually now reuse. I can actually use it more than once. So what I'm going to do next, I'm actually going to be using it twice. Okay, so this first time I'm going to use it to get the total count of all the things in the database, all the search results. So I'm going to say query.get.count, count async. So that's going to give me the whole count. Notice in this case I don't have to repeat that where clause. I don't have to write it twice, right? With the previous example that you saw, remember you had to write the where clause in both the count and the page query. Does that make sense? You had to write that twice. So if I structure it this way, I don't have to write that where clause twice to get the count and the page. So I'm getting the count using that query, and then I'm also going to grab the page. So query.count gets me the total count, and then here query order by, then by, skip and take, and then finally to list. I don't know why that's over here instead of down there, but that's where I get into that. Okay. Any questions on that?
I'm just a little confused on that first part, that queryable,
Uh-huh.
about what that does.
This part, this type?
Yeah.
Let's come back to that.
Okay.
Okay, because I'm kind of dancing around it right now. Because there's a little bit hidden in, it's a very important part, but it's a little bit hidden as to why that is. Because I want to look at the whole structure and then come back to look at why that is. Okay, so yes, the thing you do need to know about it, and this is kind of part of why I'm doing it here, is as long as I use that iQueryable, I can use that query again. And remember we talked about deferred? Remember a bunch of these methods are deferred? You remember that where is deferred, right? So until I get down to count, which is not deferred, or until I get down to toList, which is not deferred, these queries don't run. Does that make sense? Effectively, I'm building up a query in memory until I finally call count, which actually turns it into SQL and runs it. Or I get to toList, which finally turns it into SQL and runs it. So I'm actually going to be running two SQL queries here, right? So the first SQL query is to get the count. The second SQL query is to get the page. Okay? That's part of what iQueryable allows me to do. Okay? So that's part of what that allows me to do. Is it helps me build up those queries and then run them when I want to. Okay? Well, let's talk about where do I get this? Well, first of all, we know iQueryable. We know it starts with an I, right? What does it mean that it starts with an I? What does that mean, typically? It's an interface, right? So I know iQueryable is an interface, okay? So by telling you that this is valid code, what do I now know? If I know this is an interface, what do I know about things?
It'll use interface. So there's interfaces have certain methods that
Okay.
will always be used with them as
That they define, right? So an interface defines, hey, you have to implement these methods,
yeah.
right? What data type is things?
Isn't it DB set?
It's a DB set, right? So I have a DB set over here, but an iQueryable over there. How does that work?
That means DB set implements iQueryable.
Right. So DB set implements two things. It implements iQueryable. It also implements one we've seen, which is IEnumerable, right? So DB set actually implements both of those interfaces, both iQueryable and IEnumerable, okay? So the reason I'm telling it which one I want this to use is because I want to use the iQueryable methods in LINQ, okay? If I started this as IEnumerable, then everything from this point down would use the versions of this would use the where that works with IEnumerable instead of the one that works with iQueryable. That makes sense? So there's two versions of where. One version of where that takes an IEnumerable and returns an IEnumerable, and there's another version of where that takes an iQueryable and returns an iQueryable, right? So if I start with an iQueryable, I will always keep getting an iQueryable out, okay? But if I just put var here, right, what would be the data type of this if I just put var here? Would be the DB set, right? If I just put var here, this query variable would be type DB set, right? Which would mean that this wouldn't work, right? If I put var here, I would get the error down here because where returns an iQueryable, not a DB set. Does that make sense? I have to tell it what data type it is up here so that we have the right data type down here. Okay? So I've got, as I kind of mentioned previously, I could put IEnumerable here, right? So this does implement IEnumerable. All this where logic down here would still work on IEnumerable. If I put the word IEnumerable here, in fact, it would compile. It would compile, it would run, it would give me the correct result. More than likely. Disregarding thing down here, which secretly is being case insensitive because I'm running it as SQL. It wouldn't be case insensitive once I'm running it IEnumerable. Okay? So I could put IEnumerable here, I could put iQueryable there. Okay? The difference being, IEnumerable, remember, means that there's an iterator there. Remember we talked about that at some point? IEnumerable means that there's an iterator of some sort there. Okay? Now, iterators can just be C# code, and typically are, right? As far as that's concerned, iterators are C# code. Okay, if I just had IEnumerable there, though, that's going to prevent me from doing certain things as far as translating the LINQ stuff that I'm doing into SQL. Okay, so if I ran this, if I had that first line just be IEnumerable, you write out the SQL that would go to the server. Works. So if I sent that to the server, that would be select I want to get all the columns from things so if I wrote that as IEnumerable, if I wrote this up here as INterval, what would actually get created for both of these, both for the count and for this paging, this is the query I'm running against the database. I'm running against the database twice. You see a problem there? What's missing? What's missing from the select query? That should be there.
Thinking order by.
Okay. Well, that's for sure missing from this side. What else is missing? I'm saying regardless of what search query you give me, this is what I'm going to get if I use iQuery if I use INterval up there at the top.
Guessing the where clauses.
Missing the where clause, right? So if I just run INterval, all the rest of the stuff doesn't get kind of tacked into the query. Okay? If I use INterval up at the top, it's just going to grab all of the data from the table. It's going to grab every single row from the table and grab all the data from that. Is that maybe a bit of a problem? Grab all the data? Maybe a very big problem, because if I do that with INterval up top, now I'm working with all the data, and it's all in memory, and I have to get all of it from the database. Okay, so the whole point of why I'm using iQueryable is that I want to give it the opportunity to build up this entire SQL query before it runs it. Okay. So as long as I have that as iQueryable, it's going to go ahead and add in the where clause. It's going to go ahead and add in any of the counts. It's going to add anything else that it needs. Order by, the skip, the take, all of that's going to get turned into SQL. Okay. The difference being, so one thing to know for sure, as far as the inheritance hierarchy goes, iQueryable is actually a subclass of INterval. It actually inherits from INterval. Okay, so anything that is iQueryable is also INterval. Okay, because it's a child. Okay. Note that both of these are interfaces, right? So you can still do that. You can do inheritance with classes. You can also do inheritance with interfaces. Okay, so that's one thing to keep in mind. The difference is, so this has some methods. This adds some extra methods, and the extra things that iQueryable adds are something in C# we call an expression. Okay, expressions are used to do translation, to translate stuff that we write in C# into another language. Okay, that's where the expressions are used. Okay, now the nitty-gritty of how all that works is generally beyond what you need to know, unless you're trying to add more logic to that, to how things get generated, how things get turned. If you're trying to add additional LINQ methods, then you need to get into that. But usually we don't need to know too much about that. But you have to know that it's there. Okay? So for instance, if I am writing this LINQ query and I write a lambda method, like I've written a lambda method here, that actually gets turned into an expression, which then gets turned into SQL. Okay? It's not, this here doesn't get treated as a lambda, it gets treated as an expression, which is different. Okay? A similar thing happens anytime we're using those HTML helpers. If I'm specifying this is text box 4, x arrow x dot name, that actually gets turned into an expression, not a lambda, not a function like you might think it would be. Which is where, because it's getting turned into expression, that's where you can't use things like math and calculations when you're using those helpers. Okay? Because it gets translated into something else. So that's what iQueryable facilitates. It facilitates that translation from C# code into SQL. If I'm just writing IEnumerable, I'm doing everything in the C# world. So as soon as I turn this into, if I made this IEnumerable, the rest of this logic here is all going to run in C# instead of running in SQL. Questions? I hope there's some questions on that. Because that's kind of a deep topic.
Can this be translated into query syntax or?
Yes. Well, some of it can. You can easily do a query syntax up on this first part, but the rest of it, no. Because what effectively you're doing here, see, you're just doing where. It actually takes more lines of code to write this as a query than it takes to write this as a function, is the gist of it. Does that make sense? You could write this as query syntax. It would end up generating the same output, but it would take you more to write. So the only place where you're going to see query syntax is in this first part. The rest of that stuff really has to be functional. Does that make sense? So are there any questions on this method as a whole, on this set of code? Again, the biggest thing that is new is really this part in the middle where we're building up that where clause dynamically. The rest you've mostly seen before.
When you're getting results, is there a way to get it to order the results by most relevant to least?
What do you mean most relevant to
Like,
least?
You can have multiple things in the search query, but you probably want the things that match it closest to come first.
Yes, you can. Okay? Yes, you can. I won't go into it here because it gets a little bit into the weeds. The way that you would do that, so the way that I would do that as far as evaluating what is more relevant, well, first, as far as this is concerned, order by, I can order by any column, right? So if I had some sort of score of how relevant it is, then I could order by that relevant score. That make sense?
Yeah.
So the trick is between here, somewhere in here, you have to put a calculation for each row to figure out that score. That make sense? You put in a calculation to calculate how relevant is that row. And then you sort by that formula. Does that make sense?
Yeah.
So you have to build a formula to do that, which isn't the easiest thing to do. It can be done, I've done it before, but that's what you have to stick in the middle there. That make sense?
Yeah.
You have to add another column to the results, which is that relevance score, and then sort by it. Does that help?
Yeah, I think so.
Okay. So it is possible to do that, but it's really beyond the scope of what I'm going to ask you to do.
Yeah.
Here. So as far as deferred execution goes, there are some decent articles out there about it. This one, if you want to read more about it, I would strongly recommend going to read this. One of the things they kind of say in there is deferred execution is a subject that a lot of developers must understand if you want to get the full power of LINQ. But it's also not, according to them, it's not a particularly difficult subject, but it does require us to know to follow those chains of thoughts beyond what we typically think about in terms of imperative code, right? So to explain one of those terms in there, we talk about imperative code. That's the typical kind of programming paradigm that you see in most languages. Whether it be JavaScript is imperative, C# is imperative, C++ is imperative. The idea with imperative is that you say, do this thing, and then do this thing, and then do this thing, and there's a logical flow from top to bottom. Whereas when we look at this deferred logic, where we've got these iterators and we've got other things happening, things don't flow from top to bottom. Does that make sense? That's part of what makes keeping deferred straight a little bit difficult, because you can't think of it strictly from a top to bottom sort of fashion. Instead, the way we think about it is sort of a pipeline, right? So if I were to look at how I've structured that code up there, I'm going to start with the things table, and I have all the data in the things. So I'm starting with that, and then I'm feeding it into a where clause. In fact, I may be feeding it into more than one where clause. That's the chain I'm building up. Until finally it gets sent to, say, count. Right? So if I want to count the number of things that are in my search results, that's what my pipeline looks like. That makes sense? I think about this function, pass it on to that function, pass it on to that function, pass it on to that function. Does that make sense? I'm chaining it. Okay. Similar thing if I'm trying to get the page of results, rather than going to get this count, I go over here and I'm going to say, well, what was the first thing I needed to do to get a page? What was step one? What was that first method that I called to get that page of results? Essen? So I'm building up this pipeline, right? So remember, I start with the things table. I'm building up the where clause, and then, well, in one path I did a count here. What's the first step in this path where I'm getting a page?
Order.
It's order by, okay? So the next thing I do, I put in my pipeline, is to order the results. And that ordering includes actually both the order by and the then by. Okay, those are effectively part of that same step. Okay, so I'm going to order the results, and then what's next?
Skip.
Skip and take. Right? So the next step is take. Is there one more step after that? Or is that the last one? Huh? To list. So the way you want to think about building up these queries is you think of them as a pipeline of steps that you're pulling it through. Okay? And this kind of thinking actually gets into something we call more, this is more like functional programming. Okay? Building up this pipeline is typically how we think about functional programming, whereas imperative we think from top to bottom. In functional programming we think about pipelines.
So whenever we do like multiple where statements before, it was treated like an and, right?
Yeah, so all of this is going to get combined as an and, right? Remember, we're adding multiple where clauses in here. So all of these where clauses are getting combined as an and. which means that every keyword has to match. Does that make sense?
Right, so like if you had like John Kennedy,
Yeah.
if it was and, wouldn't it need to match John? Oh, it would need to match John and Kennedy.
You match John and Kennedy.
So it wouldn't get,
But they can be in any order.
it would get like a random other Kennedy.
Right,
Like John
right.
and,
He couldn't be Adam Kennedy because he wouldn't match both.
John, okay.
Or it can't be John Smith because it wouldn't match the Kennedy keyword, because these are combined with an and. That make sense? It has to match every keyword somehow. Which is where I'm putting these ors in here to say, well, this word could be in the name, the tags, description, or the category. It could be in any one of those places. But it doesn't have to be in all. That make sense? It has to be somewhere. Each of these words has to be somewhere in there, in that properties of the item, but they don't have to be everywhere. If you for further resources, I would definitely recommend reading through that first article. It's got a lot of relevant stuff about LINQ. There's also a video series out there by Jamie King. This is probably an hour or so of video. If you watch through that, that also will tell you more about how this deferred sort of stuff works and more some of the nitty-gritty stuff that goes into that. So I would, if you're still having questions about that, those are two very good things to look at, is that article and that video series. But what this comes down to, so we've got IEnumerable, but so one thing we talk about in here is IEnumerable versus iQueryable. Both are kind of useful. The big thing to know is as long as we're working with queries like this and we're trying to build up an iQueryable, we're trying to build up a SQL query, that's the one we want to use. So iQueryable really works well with LINQ to SQL specifically, whereas IEnumerable is something we use more with what's called LINQ to object or LINQ to XML. Okay, so LINQ to object is where we're actually working with lists and arrays, and we're working in memory. Does that make sense? So LINQ to object is a version of LINQ basically where we're working in memory, versus LINQ to SQL is where we're working with the database, and it's going to get translated in SQL. And oftentimes you'll see a mix of those two things, where you say, okay, let's do as much as we can in SQL, and then the stuff we can't, we'll do in memory. Okay? So that's oftentimes where you'll see a break, and you'll see a to-list between the LINQ to SQL part, and we get into the IEnumerable world, and we start writing things as LINQ to object. So this is in IEnumerable is fine as long as we're working with things that are in memory. But if we're working with external resources, we want to use iQueryable to allow it to build up those queries more efficiently. So we're pulling in less data. Because this supports that deferred execution stuff, whereas this prevents, if I just use IEnumerable, I don't get all the fancy expression tree stuff that happens for me. Okay. So we've talked a little bit about how to do the multi-keyword search. The next kind of group of things that I want to talk about are autocomplete and autofill. But I think we're at a good stopping point, so let's go ahead and take a break, come back at 1:45, and we'll go over the next piece. Just to fill you in on the plan, I'm planning to go through this set of this document and go through all the theory today, and we'll hit the actual sports store and do an application with it tomorrow, just because this is going to take some time to get through.